Hello everyone. So today we will have a quick revision about all the points we have discussed in this second chapter, right? So we have started this chapter with discussing about potential energy and conservative force, right? Conservative forces is a force having certain property that total work done in bringing a particle from one point to another point is independent on the path traveled by the particle, right? And such forces are called as a conservative forces, right? Example for conservative forces are gravitational force, electrostatic force, and also spring force. Spring force is also example for conservative forces. So after that, we have discussed electric potential, right? Electric potential at a point is defined as the uh, it is work done in bringing a particle or charge. It is work done in bringing a unit positive charge from infinity to that point against the electric field. So what is electric potential? It is the work done in bringing unit positive charge from infinity to that point against the electric field, right? That is electric potential we have discussed, right? And SI unit or else equation for electric potential in general, that is according to definition, electric potential is equal to work done divided by the charge. It is according to definition, right? Due to point charge and due to electric dipole, you have discussed the different formula, but according to definition, electric potential V is equal to work done divided by the charge, right? So afterwards, what you have seen, we have discussed about SI unit of electric potential, right? So SI unit of electric potential is volt, right? How to define volt? So electric potential, right, at a point is said to be 1 volt. When, right, when it is said to be 1 volt, 1 joule of work done is in bringing 1 coulomb unit positive charge from infinity to that point. So what is volt? Volt is the, it is the work done, 1 joule of work done in bringing unit positive charge from infinity to that point. That is called as a volt. So after the definition of volt, what you have seen? We have seen the expression for electric potential, right? Or equation for electric potential due to a point charge, right? So to calculate that electric potential, what you consider? You have consider the unit positive charge, right? That unit positive charge is surrounded by a some electric field, right? And you have kept a point charge, right? Point charge and unit positive charge. We have calculated electrostatic force between them, right? Force of attraction we have calculated, right? We will get that F is equal to something equation, right? Afterwards, what you have did, you have moved that unit positive charge with small distance delta r dash, right? And we have calculated work done for that, that is delta w, right? And to get total work done, what you have did, we have integrated that small delta w, right, from infinity to r. Then we got the final equation as V is equal to Q divided by 4 pi epsilon naught R. It is the equation for electric potential due to a point charge. So next, what you have seen after that point charge, we have seen electric potential due to electric dipole, right? So to calculate that electric potential due to dipole, what you did, we have considered electric dipole first, and we have considered a point P at a distance r from the midpoint, right? Then we have calculated electric potential due to plus q and minus q charge first, right? V1 and V2. Then we added V1 plus V2, right, to get a total potential at point P, right? In that V1 plus V2 total potential equation, we have got some two unknown things, that is AP and BP, the distance between plus q charge and point B, and also the distance between minus q charge and the point P. So to calculate that AP and BP, what you did, you have draw a perpendicular line to the OP from A and P, right? Then in by considering the case of cos theta, you have calculated the value of AP and BP, and we got the final equation. What is that final equation? Tell me. That equation is V is equal to 1 divided by 4 pi epsilon naught P cos theta, what? P cos theta divided by R square, right? P cos theta divided by R square. So these all points we have discussed till now. And today we'll discuss some new concept in the second chapter only, that is equipotential surface. Equipotential, the word itself says that equal potential, right? Equipotentially word itself says that equal potential surface, right? So what are equipotential surface, we'll discuss in today's class. So equipotential surface means it is a surface which has the same potential at every point on it, right? Now consider a surface. Now see, look at this figure. Consider this outer surface. Consider outer surface. There are 2 points, A and B. A and B. So it is in the middle, the center of this circle is plus charge. You are seeing, right? That is point charge. Only single charge is there. Only one charge. Means it is a circle, last circle, and you have considered 2 points A and B. Now, what are the electric potential at point A and at point B? You have to see. Then you will understand what is equipotential surface, right? To calculate electric potential at point A and point B, first you have to consider equation, right? Which equation you have to consider here? Now, till now, you have three equation for electric potential, right? First one is V is equal to work done divided by charge. Second one is V is equal to Q divided by 4 pi epsilon naught R. Third one is V is equal to 1 divided by 4 pi epsilon naught P cos theta divided by R square, right? Total three equations are there. So which equation you have to use to calculate electric potential at point A here? Which equation you have to use? See, here it is a point charge, Q is a point charge. So you have to use second equation, electric potential due to point charge, right? Look at this equation here. It is your second equation, 1 divided by 4 pi epsilon naught Q divided by R, right? So this equation you have to use to calculate the electric potential at point A, right? So observe this equation clearly. See, in this equation which thing is variable and which all things are constant, that you have to see, right? 1 divided by 4 pi epsilon naught is the constant, you know it is constant for all the things, right? 1 divided by 4 pi epsilon naught. And in this case, in this equipotential case, this Q is also constant because you are having only one charge, right? It is one point charge, right? Then only differ in the distance, R will be variable. Now look at point A and B. For point A and B, look the value of for R. It is constant or it is variable? It is same or it is different? Tell me. Point A and B, the value of this R is same or different? Right? It is obviously same because they are at the surface like a circle, right? On the perimeter of a circle, means radius will be same for all the for that outer surface perimeter, right? So R value will be same for both point A and B. R value will be same means V value will be same, right? Because all things are constant here now, right? For A and for B, for both points, you will get same value of electric potential. Same value in the sense equal value of electric potential, right? Then this surface, outer surface, you can see this surface is called as a equipotential surface. Why it is called as equipotential surface? Because it is having equal value of electric potential at all the points on it. Clear? Such surfaces are called as a equipotential surface, right? Now for a single q charge, understand what is equipotential surface, right? Equipotential surface is the surface having equal value of electric potential at all the points on it, right? Now for single charge q, equipotential surface are the concentric circle. Concentric in the sense is what? Concentric is nothing but having common, concentric, common center. Concentric is common center. These all circles, see here in this diagram, How much circle you can observe here? 1 2 3 4, total 4 surface, 4 circles you can observe, right? For that all 4 circles there is only one common center, right? That is plus charge is there, that is at a common center. Origin is common for all the 4 circle, and such circles are called as a concentric circle, right? For point charge, equipotential surface are the concentric spherical surface. Clear? So it is equipotential surface. Now we'll see the relation between electric field and electric potential. The relation between E and V. We have to see. We have to see a equation for relation between E and V. How these two quantities are related. E means electric field, V is electric potential. Right? To derive that relation, you have to consider this diagram. Right? Now imagine we have two equipotential surface. We have how much? Two equipotential surface. One is surface A and one is surface B. And surface A has the value how much? Surface A has the potential value this much, V plus delta V, and surface B has the value V, right? Now potential value of your surface B is V, and potential value of your surface A is V plus delta V. Both are having different potential, but both are itself is the equipotential surface. So every point on the surface A is having same potential, like that every points on the surface B has same potential, right? Now consider a point P on a B surface, right? Now make a correction in this diagram. This surface is B and this surface is A. Lower surface, they are placed one above the another, right? It is lower surface, it is upper surface, one above the another they have placed, right? Below surface is surface A, upper surface is surface B. Now consider a point P on the surface B. It is surface B, right? Consider a point P on the surface B, and dl is the, or delta L is the perpendicular distance between surface A and point P. So P is the point on the surface B, right? And dl is the perpendicular distance, straight distance between surface A and point P, right? Now suppose a unit positive charge is placed at point P. Unit positive charge means having 1 coulomb charge. Suppose it is placed at P and it has moved from P to A in this direction. From surface B to A it has moved. Unit positive charge is placed at point P on the surface B, placed at point P on the surface B, and it has moved through this distance delta L, perpendicular distance delta L from B to A. What will happen if unit positive charge is moves from one point to another point? A work will be done, right? And that work is stored as a potential energy, right? So how that work is called as a delta, sorry, magnitude of E, modulus E into delta L. Magnitude of E means it is nothing but electrostatic force. E is here electrostatic force, you can say. Electrostatic force F is equal to magnitude of your E. It is equal to E. So in place of F, you have calculated you have placed a electric field, magnitude of electric field. So magnitude of electric field is nothing but a force. So force into displacement is a work done, right? Right? This work done is given by, this work done is given as a potential difference between two surfaces, right? Surface A is also having some potential, surface B is also having some potential, right? And your unit positive charge is moving from surface B to A, right? And total potential will be how much? The potential at surface B and potential at surface A. The difference between these two potential gives you the total potential, right? So here it is. Here it is given, right? See, see here. Potential difference is potential at a surface A and potential at a minus potential at a surface B. This gives you the work done in moving a unit positive charge from P to A here. So E delta L is the work done. It is work done, right? And it is the potential difference. This much is understood, everybody, right? So it is the work done in bringing unit positive charge from surface B to A. So next we'll see how this equation. Now see, it is work done and it is potential difference. V is the potential at surface A minus V plus delta V is the potential of surface B. So VA minus VB. This is the VA minus VB, right? That is equal to, and open this bracket, V is equal to minus V and minus delta V. This much you will get if you open the bracket. Then in this step what will happen? This V get cancels, right? It is plus V, it is minus V. So what will remain? Minus delta V. So E dl or work done is equal to minus delta V. Now we want to calculate relation between E and V, right? Here it is E and here it is your V, right? So to calculate that relation, transfer this delta L this side. What will happen if delta L comes this side? It will come in the denominator. So electric field is equal to the ratio of potential and the distance or displacement. So E is equal to minus delta V divided by delta L is the relation between electric field and the distance, right? And this equation can also be written as E is equal to magnitude of E is equal to magnitude of V. If you consider this modulus sign, what will happen? This negative sign will go on, right? You have to consider only magnitude, means positive will come, right? So modulus of E is equal to modulus of delta V divided by delta L is the final equation. So this is the relation between electric field and electric potential. So further things we'll see in next class. Thank you.